Hi, my name is Cooper, and for Assignment 5, I built a smart voice assistant with a cloud-connected web dashboard. This system uses the M5 Stick as a wearable client device that communicates with a publicly deployed Python server over Wi-Fi. The device can display a rotating to-do list, record voice notes, and send audio data to the cloud. On the back end, I built a server that handles incoming requests, stores data in the database, and processes audio into transcribed text. I also created a web dashboard that allows users to manage to-dos, view voice notes, and interact with the system in real time. All components are deployed publicly and secured with authorization to prevent unauthorized access. Before entering the dashboard, users must authenticate their identity. When they log in, they must use a specific username and password, which for now simply match to make sure I didn't forget, to enter the website. Now that I'm logged in, this is the main web dashboard. Here, I can see all of my current to-dos items along with any previously recorded voice notes and their transcriptions. The dashboard is connected directly to my backend server, which manages all data using a database. To demonstrate functionality, I'm going to add a new to-do item right here. Now, I'll demonstrate the M5 client receiving and displaying the to-do list from the server. The device automatically sends a request to the backend every 60 seconds to retrieve the latest to-do item. As you can see, the to-do item I just added on the dashboard now appears on the device. Using the secondary button, I can cycle through the different to-do items stored on the server. Each button pressed sends a request to move the next item in the list. This demonstrates the real-time communication between the embedded device and the cloud backend. Next, I'll demonstrate how the M5 can modify data on the server. While viewing a to-do item, I can press and hold the secondary button to mark the item as complete. When I do this, the device sends a request to the backend server, which updates the database by either marking the item as done or removing it. Now, if I go back to the dashboard, we can see that the to-do item has been updated or removed, reflecting the change made directly from the device. This confirms two-way communication between the embedded system and the cloud backend. Next, I would like to demonstrate the voice recording functionality of the M5 Stick. By pressing button A and then pressing button B, we can cancel the voice recording. By pressing button A, what is the square root of 15? And then pressing it again, our M5 will record our message and give us a response. If the response is too long to fit on the screen, we can simply press button B to scroll through the text. After stopping, the device uploads the recording audio to the backend server. The server then processes the audio and converts it into text using a speech-to-text system. If I switch to the web dashboard, I can now see the recording audio along with the transcription displayed in the table. Simply press and show transcription, shows you transcription. You can also hear the audio. What is the square root of 15? Finally, for my creative extension, I implemented an AI-powered voice note processing system, which uses a large language model. After a voice note is recorded and transcribed, the backend sends the transcript to the model, which generates a short summary and automatically extracts multiple actionable to-do items from a single voice note. For example, today I would like to go fishing, hunting, ride my bike, and clean my dishes. We can use B to scroll down. And now when we refresh, we should see our to-do items. My final note, to switch between Assistant and To-Do, you simply hold the A button down. And to scroll through to-do items, you also use the B button. To cancel anything, you hold the B button down, and it marks it off your list. To go back to Assistant, you hold A.